Hi, this is Deakin University SIT192, Discrete Mathematics Presentation 2. I am the presenter, Winnie Ang Wan Lin. Student ID 215-316-238. In today's presentation, I'll be looking in question 2. Mathematical induction as introduced in week 6 is termed as simple or weak induction, as we will be explaining the concept of strong induction and also use a work example that is appropriate for this unit. Let's get started, shall we? First, let us get to know strong induction. Strong induction is a type of standard induction, and it assumes that the statement holds for all values before k. There are also a difference in the induction hypothesis between the strong induction and the weak induction. It also assumes that all of P1, P2, until Pk are true to prove Pk plus 1. Next is the definition, the steps for a strong induction. Step 1. Demonstrate the base case. This is where you verify that Pk0 is true. In most cases, K0 equals 1. Step 2. Prove the induction step. This is where you assume that all of Pk0, Pk0 plus 1, Pk0 plus 2, until Pk are true, our inductive hypothesis. Then show that Pk plus 1 is true. After all that introduction to strong induction, we look at the example of proof of the similarity to standard induction. Example 1. Every integer n bigger or equals to 2 can be written uniquely as the product of prime numbers. The base case for this example is clearly true for n equals 2, and the inductive step is suppose the statement is true for n equals 2, 3, 4, until k. So if k plus 1 is prime, this question is done. Otherwise, k plus 1 denoted by Pk plus 1 equals P times n. K plus 1 equals P plus n can be written uniquely as a product of primes. Continue to example 2. Proposition if n some natural integers, then 12 divides in power 4 minus n power 2. We will do it in weak induction first. In weak induction, base case we need to prove that 12 divides 1 power 4 minus 1 power 2 equals to 12 divides 1 minus 1 equals to 0, which is divisible by 12. In the induction step, we assume that 12 divides k power 4 minus k power 2 is true, such that n power 4 minus n power 2 equals to 12a for some natural integers. We then need to show that k plus 1 power 4 minus k plus 1 power 2 equals to 12b for some natural integers. As you see in the direct proof, there is no solution to this question for weak induction. Let us use strong induction to solve and see. From the weak induction, n equals k minus 5 implies that the statement is true for k plus 1. So we need to expand the base case up to n equals 6. Continue to the induction step. Let k bigger than or equals to 6 some natural integers and assume that 12 divides m power 4 minus m power 2 for 1 smaller or equals to m smaller or equals to k. Prove that 12 divides k plus 1 power 4 minus k plus 1 power 2 is true as well. Define I equals to k minus 5, for which we assume the proposition to be true, such that I power 4 minus I power 2 equals to 12a for some value of a. Show that 12 divides I plus 6 power 4 minus I plus 6 power 2 is true, by using direct approach as shown below. As shown in the direct approach, this statement is clearly divisible by 12, and thus prove the proposition. And that's the end of my presentation for today. Thank you for your time and goodbye.